Hello and welcome to today's ACM Learning webinar. This webcast is part of ACM's commitment to lifelong learning and serving the over 100,000 computing professionals and students who are ACM members. I'm Will Trace, Lockheed Martin Fellow Emeritus and Chair of ACM SIGSOFT, the Special Interest Group on Software Engineering. I'm also a member of the ACM Professional Development Committee and have served as the editor of ACM SIGSOFT Software Engineering Notes. For those of you who may be unfamiliar with ACM or what it has to offer, ACM offers educational and professional development resources that boost your skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM learning resources at learning.acm.org. You can see some of those highlights on your screen. ACM recognizes the role of computing in driving the innovations that sustain competitiveness in the global environment. As such, ACM provides timely computing information published by ACM, including communications of ACM and Q magazines, access to the ACM Digital Library, the world's most comprehensive database on computing literature, and international conferences that draw leading experts on a broad spectrum of computing topics. Furthermore, we support education and research, including curriculum development, teacher training, and the ACM Turing and ACM Infosys Foundation Awards. ACM enables its members to solve critical problems using new technology that enriches our lives and advances our society in the digital age. And I might add two things. First, Google generously has increased the Turing Award to $1 million. That's a lot of money. And second, ACM membership is really inexpensive. That's not a lot of money. And if you can't afford a full membership, you might look into joining one of the 37 special interest groups. Of course, I'm biased about ACM SIGSOFT, where student memberships start at $10 and professional memberships start at $20. Okay, housekeeping. Before we get started, once again, for those who are first-timers, I'd like to quickly mention a few housekeeping items to show on the slide in front of you. In the top right-hand corner of the slide area of your screen, there is a button that will allow you to enlarge the slides. You may want to enlarge the slides at any time by dragging the corner of the slide window. The slides will advance automatically throughout the event. During the presentation, you can minimize the slide area, question and answer, and bio screens using the buttons on the bottom panel. You can also use a number of widgets also found at the bottom panel, including Facebook, Twitter, Wikipedia, and a resource list where you can get copies of the slides. If you're experiencing problems with our web interface, please refresh your console by pressing the F5 key in Windows, Command+R if you're on a Mac. Refresh your browser if you're on a mobile device, or close and relaunch the presentation. You can also visit the webcast help guide by clicking on the help widget below the slide window. Obviously, to control volume, please adjust the master volume on your computer. And at the end of the presentation, as usual, we will have time for questions, and we hope you have several. If you think of a question during the presentation, please type it into the Q&A box and click on the submit button. You don't need to wait until the end of the presentation to begin submitting questions. You may also use the Q&A box and the survey at the end to suggest topics for future webinars. At the end of the presentation, you will see a survey open in your browser. Please take a minute to fill it out and help us improve our webinars. This session is being recorded and will be archived. You will receive an automatic email notification when it is available, and you can check learning.acm.org in a few days for updates. You can also use Facebook and the Twitter widgets on the bottom panel to share the presentation link with your friends, as well as to tweet comments and questions using the hashtag #ACM Webinar Judge, J-U-D-G-E. We'll be watching for those tweets. Today's presentation is Stranger Than Fiction, Case Studies in Software Engineering Judgment by Steve McConnell. Steve is the CEO and Chief Software Engineer at Construct Software, where he consults to a broad range of industries and oversees Construct's consulting and training offerings. Steve is the best-selling author of the industry classic Code Complete, as well as Software Estimation, Demystifying the Black Art, Rapid Development, and other titles. Steve has served as editor-in-chief of IEEE Software Magazine and chair of the IEEE Computer Society's Professional Activities Board. finally, readers of Software Development Magazine voted Steve one of the 3 most influential people in the software industry, along with such guys as Bill Gates and Linus, I can't pronounce his last name, Torvalds. Yes. Steve, we look forward to your presentation here today.
Will, thank you for that great introduction, and I'll put in a second plug from Will for joining SIGSOFT. That's how I got to became aware of Will in the first place. I've enjoyed his writings in that capacity for a long time, and I'm really happy to be here today to talk about case studies in software engineering judgment, stranger than fiction. We have a fairly ambitious agenda for the talk today, and the title should be taken quite literally. Case studies in software engineering judgment. That means that we're going to talk some about judgment, maybe more than you would have expected, but we're going to talk some about that. I'm going to present a model that is one possible way to support better judgment in software engineering, and then we will look at a few case studies in applying software engineering judgment. I think that this is a pretty important topic. We're going to just really hit the tip of the iceberg today, but I think you'll at least get enough of a flavor of it to see that there actually is a pretty important issue here. So, turning then to that first topic, the topic of judgment, I think a good way to look at judgment is through something known as Bloom's Taxonomy. Bloom's Taxonomy is often used in, I think primarily used in education circles, typically for the design of class materials or perhaps exam questions. I think it actually is often treated as though it's kind of just a superficial description of something, but I think if you really study Bloom's Taxonomy, it yields some really significant insights for software engineering. Bloom's Taxonomy basically lists levels of understanding going from knowledge and comprehension and application down to analysis, synthesis, and judgment or evaluation. We will talk about each of those in some detail. So as now we officially see on the slide, I think Bloom's Taxonomy is often treated almost superficially or even flippantly, but I don't think it's an overstatement to say that a real understanding, especially of the upper levels of the taxonomy, which is to say analysis, synthesis, and judgment, has profound implications for software professionals. So the first level, as you see, typically represented as the bottom level on a pyramid, is knowledge, or also known as recall. This is the remembering of previously learned material. We see recall or knowledge in software engineering when we, for example, recall book learning, or we recall personal experience, or we recall specific details needed to implement a particular technical practice. Certainly recalling patterns of practices would fall into that knowledge category, and recalling successes in design, code, test, project management, and so on would also be examples of recall or knowledge. The next level up is comprehension. Comprehension refers to grasping the meaning of material. And this would be the lowest level of understanding, according to Bloom's Taxonomy. Examples in software engineering would include summarizing a methodology, so not just recalling details, but summarizing it, which would show comprehension. Explaining Scrum, either in words or as a diagram, being able to explain a concept in different forms would be a sign of comprehension. Describe an example of Scrum would be one kind of comprehension. Explain why Scrum is not a design approach, so you can see how that goes beyond simple recall. Or explain how Scrum is different from extreme programming. Those are all examples of comprehension, and I think you can probably see how that contrasts with recall, which is a lower level on Bloom's Taxonomy. The next level up is application. And in application, we use the knowledge from the recall level as well as comprehension to solve problems in new and concrete situations. So in software engineering, that would include examples like using general design knowledge to solve a specific design problem. So in other words, applying our general knowledge to a specific case. That's application. Or using general project planning knowledge to plan a specific project, or general software construction knowledge to write a specific piece of code. So this is considered in Bloom's Taxonomy to be another level up in the taxonomy. The next level up is analysis. And analysis consists of breaking a problem into its parts so that its relationships and organizational structure can be understood. We do an awful lot of analysis in software engineering. Some examples would include breaking a large class into two smaller classes, or breaking a class into methods and data. Certainly when we allocate functionality and data to methods within a class, that would be another example of breaking a problem into its parts. Finding flaws in a proposed design. Basically, we use phrases like pick something apart. That is fundamentally describing analysis. That is breaking something into its parts. Finding the source of a coding error, tracking into the code, i.e. looking at increasingly fine levels of detail, would be another example of analysis. Now, I'd like to dwell on analysis for a little bit because this is really key to the practice of software engineering. Analysis is also known as critical thinking. And in the software field, at least at the practitioner level, we screen extensively for analysis skills as an entry criteria for entering the programming profession. The whole idea of programming, identifying the correct sequence of operations in a section of code, is fundamentally an analysis activity. Identifying boundary conditions, identifying off-by-one errors, those are fundamentally analysis activities. And I think it's important to understand that these are not common human skills. Most of the human race does not find it that easy to identify the exact correct sequence of operations. And I don't know how many of you might have approached programming in your younger days, but I still remember when I was first learning my first programming language, I remember how brain-busting it was to have to think through the steps in a program line by line, keeping in mind that certain things had to be done before other things, and the holistic sense of the thing didn't matter in that I couldn't just put everything down that needed to be done and assume it would be done in the correct order. I found it to be quite a challenge at first to get things listed step by step so that I didn't do the dependent step until I had done the antecedent step. And I remember how much that hurt my brain at first. Of course, a couple years later, I was doing that sort of thing in my sleep, as is probably everyone on this webinar. But I think it's good to understand that these are not common human skills, and most of the human race doesn't really possess these skills to any significant degree. And the interesting thing is that most software professionals are really, really good at analysis, and that is partly a strength and partly a weakness, as it turned out. I would say that analysis often constitutes an overdeveloped muscle for many technical staff. Developed is fine, but overdeveloped really means that it's out of balance or overly strong compared to the next two highest levels on Bloom's taxonomy of synthesis and evaluation. When we have overdeveloped analysis skill, that can lead to the common problem that's so common it has a name, analysis paralysis. It can also lead to excessive focus on individual details. And I think this is almost a cliche in software that people who can be quite excellent in some respects actually can have an inability to see the forest for the trees. They become excessively preoccupied with things that are very specific and really maybe don't have that much general importance. So let's talk about synthesis for a moment. We'll come back and revisit analysis in a little bit. Synthesis is the next highest level on Bloom's taxonomy, and this is putting parts together to form a new organization or whole that requires original or creative thinking. And in software engineering, some examples would include things like combining two classes into one new class that provides an interface at a different level of abstraction. So that would be a good example of synthesis, I think. Making global versus local trade-offs in design of a system to create a better overall design. The whole idea that the considerations globally might not simply be enumerating the entire list of local trade-offs, but we might get into something that's qualitatively different at the global level would be a synthesis kind of idea. Assembling a team based on strengths and weaknesses of a particular set of individuals, rather than thinking there is one archetypal best contributor and trying to have as many of those people as we can, the idea that we would assemble a team based on a diversity of strengths and weaknesses and that the whole would somehow be greater than the parts would be a synthesis activity. Adjusting overall project plans based on progress of a set of individual teams, so this is really at the executive management level, would be a synthesis activity. In Bloom's taxonomy, synthesis, or create, is one of the highest levels of understanding. Let's dwell a little bit more on synthesis. So synthesis is also known as creative thinking. And under Bloom's taxonomy, as you can see from the way it's represented as a pyramid, this is a higher level skill, and not as many people are good at it. I found over the years that technical people often discount the value of synthesis. For example, it's very common for technical staff to be skeptical of upper management, which really by its nature needs to be more focused on synthesis and creation than on analysis. And so we actually see not just an underappreciation, but often a disrespect for the whole synthesis activity. I think the bottom line here is that the software industry does a much better job of recruiting and screening for analysis skill than we do for synthesis or creative skill, despite the fact that you could see from the list of activities that I listed under synthesis that there are some really important activities that fall under that umbrella. The top level in Bloom's taxonomy is judgment or evaluation, and that means evaluate the value of ideas, concepts, principles, or solution methods for a given purpose. And like synthesis, evaluation is one of the highest levels of understanding. Now, interestingly enough, judgment or evaluation has been applied to Bloom's taxonomy itself. In the original version of Bloom's taxonomy created in 1956, the terms were nouns going from knowledge to evaluation, with the two top levels being synthesis second and evaluation first. The taxonomy was revised in 2001 to revise the terms to be verbs rather than nouns, and the two top levels were essentially switched, so that in 2001 the thinking was that evaluation was the second highest level and create was the highest level. So kind of an interesting application of judgment to Bloom's taxonomy itself. I personally interpret it more like this, to say that I'm not sure that I believe that either create or evaluate is the thing at the top. I think they are both at the top. I think they both feed off each other, and they both depend on analysis. So really, I think what we have is really kind of two things at the top. There may be others who know more about Bloom's taxonomy than I do who would dispute that, but I think that's a pretty good way to look at it. So what are some examples of judgment in software engineering? Well, choosing the better of two technology paths. Okay, that's something we need to do fairly often. Choosing the best of three design approaches. That's something we need to do very often. Justifying a re-architecture project. Kind of interesting. You know, when is the right time to actually make that leap? Well, there's a lot of judgment involved in that. Choosing which proposed projects best support a business's objectives. Clearly, that involves making some judgments or evaluations. Assessing the degree to which a new methodology will benefit an organization or harm it. Certainly an example. Predicting the likelihood of success of a project plan. Another good example. Or conducting root cause analysis on a failed project. That's, I think, actually the one that is maybe the most questionable, particularly because it has the word analysis in it, so that makes it sound like maybe it has more to do with analysis. But the point here is it's not just about the analysis, it's also about picking which factor actually, or factors are actually the ones that made the difference. So identifying the factors would be analysis, but then discriminating among the factors and picking correctly the ones that actually matter, that would be the judgment activity. Now I think the difference between analysis and judgment can be sometimes a little bit hard to grasp, but the basic idea, I think a way to look at it, is that the analysis is the ability to go very far down a decision tree and along multiple paths. So the ability, and I don't know how well you'll be able to see this on your screen, but the ability to go way down to a fine level of detail and then discriminate by going down other branches far down the tree, going down to other fine levels of detail, and being able to organize and keep those straight and understand, comprehend all those paths at a fine level of detail would really be characteristic of analysis. Now, judgment, on the other hand, really has more to do with deciding which path is the right path to go down for a particular purpose. And this is something where a lot of technical people get hung up because they're so focused on the analysis that they don't look at the very top decision and say, you know what, we can go deep in the tree, but that very first decision was actually the one that was wrong. And from a judgment point of view, we might very well have a circumstance where any path on the right is better than any path on the left, and further analysis on the details of the path on the left is not going to change that fundamental decision because we actually made the right or wrong decision at the very, very first decision on the tree. And so this is something that a lot of technical people who are very analytically focused have a really hard time wrapping their brains around. They have a hard time wrapping their brains around the idea that in some cases further analysis doesn't matter, that it's okay to ignore details, that more details are actually not going to influence the overall outcome of the decision. And so this would be characteristic of judgment, not analysis, but judgment. To the degree that technical people are uncomfortable with that, it's symptomatic of that overdeveloped analysis muscle and maybe an underdeveloped judgment muscle. So one of the other interesting aspects of analysis and judgment is because we're so analysis heavy in software, we often mistake analysis for judgment. We'll be in circumstances that really do call for judgment. We'll see a heavy application of analysis instead, and we'll think that that's judgment even though it's not. So examples might be something like criticizing each of two technology paths. That's not judgment. That is analyzing each of the two paths. Finding faults in three design approaches. Well, if you're tasked with choosing the best of three design approaches, then it kind of looks like if you were to find faults in each of those three, that might kind of be sort of like judgment. But actually, finding the faults would be the analysis step, and that would need to be followed by a judgment step. Depending on how blatant the faults are, there might not be a lot of analysis needed actually, because the right path might actually be determined much higher in the decision tree. Identifying limitations of a current system to justify a re-architecture project. Identifying the limitations, fundamentally an analysis task. Advocacy for projects doesn't get beyond advocacy of one favored project. So that's interesting too. We can advocate for one project, but that doesn't imply judgment. It really implies a lower level on Bloom's taxonomy. Assessment of a new methodology amounts to religious advocacy for one methodology. So again, their assessment is kind of in that same family as evaluate or judge, and advocacy for one thing is not the same as assessment of a set of things. Assessment of project plans focuses on minutia. That's the whole idea of not being able to see the forest for the trees, and we certainly see that fairly often in our field. Or root cause analysis on a failed project consists of rehashing unpopular decisions. Same kind of issue where, again, rather than really doing judgment, as counterintuitive as that might be for something called root cause analysis, instead of applying judgment, we actually get hung up on just looking at, again, at details that may or may not really matter. So judgment capability, in my view, is even rarer than synthesis in software engineering, and I think we hardly screen for judgment in our recruiting and recruiting practices at all. For example, Microsoft's famous interview questions are nearly all about synthesis, which is higher on Bloom's taxonomy than typical interview questions are, which are often more about analysis. But poor business judgment is so common among technical staff that it is a cliche. If you spend much time with C-level, that is CEO, COO, CFO executives in companies, they just shake their heads at the business judgment demonstrated by technical staff, and I've had numerous experiences where I would actually confirm that myself. So rather than just kind of saying, wow, that's terrible, too bad we have to live with that, the $64 question is then, how do we develop good judgment in software professionals? If they don't come by it naturally and if we're not recruiting for it, how do we develop that good judgment so that that's not a weakness of our field? And I think there are a variety of ways to do that, but a way that I will propose today is use of what I call the 4 factors model. I have another presentation that goes into a lot of detail on the 4 factors model, but I will just summarize this very briefly today. The 4 factors model basically says that if we have a deep understanding of the influence of project size or the product size, of the role of uncertainty in software projects, of the role that defects play, and of human variation, and of the myriad interactions between these 4 factors, we have a good understanding, a deep understanding of those 4 factors. That goes a long way toward explaining everything you need to know, basically, about software project dynamics. I'm not going to go through these in a huge amount of detail, but size would include things like the idea of diseconomy of scale, the notion that the larger the project gets, the lower per-person productivity becomes, failure rate of large versus small projects, specializations of large versus small projects, mix of different kinds of activities on large versus small projects, and so on. Uncertainty, huge topic. Could be spend many hours lecturing on that, but includes the notion of intellectual phases, which I've talked about a lot, but otherwise hasn't really achieved much currency. Cone of uncertainty, which really has achieved some currency, and other topics that you can see on the slide. Defects, really understanding the notion of defect cost increase, of the effect of lag between defect insertion and defect detection, the effect of different defect removal techniques and the consequences of putting those into a series of removal techniques and so on. Again, lots and lots of details that are worth talking about there. And then human variation. I think a huge factor that doesn't get emphasized enough, especially not in a research context, frankly, because the human variation actually undermines a lot of the research that's been done if we take it seriously. And yet, if we really want to get to a point where we have consistently successful software projects, I think it's really important to understand the ins and outs of how human variation affects software project dynamics. So that's a very, very brief introduction to the 4 factors. So the 4 factors model, essentially, if we spin it the right way, can provide a set of templates against which we compare what we see on a project versus what we would expect to see on a healthy project. And I think that that can support judgment. I mean, if we think about how people commonly talk about judgment, we often talk about it as though judgment is something that comes significantly from experience. And experience really is actually something that kind of, if you think about it, involves creating mental templates. It's a process of creating expectations based on having seen similar things over and over again, and then judgment can be supported by comparing something new to the expectations that we have formed based on seeing a variety of things in the past. That would be one way to apply judgment. So one example of using the 4 factors model to support judgment would be to create checklists based on the 4 factors. And so I'm not going to read through every point on these slides. As Will said in the introduction, the presentation will be recorded and archived and available. So if you're interested, you can come back and take a look at these details later. But we would have a checklist related to size. And it would have questions like, is the project estimated close to its actual size? And that would imply, are the project plans really scaled appropriately for the size? Does the project schedule permit completion of a project of the estimated effort? Other questions like, do we have appropriate staff specializations for the size of the project? Do we have appropriate management for the size of the project? And so on. So basically a cluster of issues related to size. And we'll get into more details on that when we look at the case studies. Second of the 4 factors would be uncertainty. And here too we have questions like, do the project's estimates and plans account for the cone of uncertainty? Where will the project's challenges come from in terms of the intellectual phase profiles? Are we addressing design uncertainty in an appropriate way? Are we addressing requirements uncertainty and technology uncertainty in appropriate ways? And other questions along these lines. And again, we'll get into the application of some of these as we look at some of the case studies. We also have a defect checklist. Again, you can look at the details at your leisure, perhaps after the talk has been archived. But we're really looking at how effective is the approach the project is taking to detecting and removing defects in a timely way. Really, these questions amount to answering that question. And finally, human variation. Again, here, lots of important questions. Do the people on the project have the skills needed to complete a project of the intended size? Do they have the skills needed to complete a project with the uncertainty characteristics demonstrated on the project? Do they have the skills needed to deliver software at the intended or target quality level? These are the kinds of questions we look at when we want to talk about human variation. So these checklists really are intended for purposes of illustration. I think they are reasonable presentation of checklists for presentation purposes. They aren't necessarily the be-all, end-all checklists. Somebody who wanted to spend a lot more time looking at these might be able to come up with better checklists, but I think they're good enough to get the idea across of how we could package these up and put them into a model that would actually allow us to practice using judgment in looking at software projects. And so really what I've done for purposes of this talk is to create a simplified model where we simply have a red, yellow, green classification for each of the 4 factors: size, uncertainty, defects, and human variation. So with all that as prologue, given that the title of the talk is Case Studies in Software Engineering Judgment, that lays some groundwork for the judgment part of the talk. Now let's go ahead and take a look at the case studies part of the talk. And here we will look at a handful of case studies, some of projects that went well, some of projects that didn't go so well, and apply that 4 factors model and see if we can actually essentially practice applying judgment to software projects. The first case study, the value of case studies, I think, is that we can improve judgment. I think understanding the 4 factors model, which is really kind of baked into the way I'm presenting the case studies, also supports synthesis or creative in the Bloom's taxonomy sense. In that, we really need to be applying synthesis or creative in planning and management. And so really this is all just very condensed form of practice of applying judgment. You know, real experience can be a great teacher, but it takes a long time. I really am a fan of case studies for condensing that kind of experience into a much shorter time frame. So the first case study I'd like to take a look at is Healthcare.gov, certainly the highest profile challenge software project we've had in recent years, and I think one that really does benefit from a look at the factors that were in play on that project. So the background for people who don't read the newspaper every day in the U.S. is that the Affordable Care Act was passed in December of 2009, signed into law in March 2010. Private sector development contracts were awarded in 2011. The original project budget was about $100 million. Coding by CGI, the prime contractor, began in spring 2013 for October 1st, 2013 go-live date. Now, if you know anything about software project dynamics, right away you should be nervous about that statement. Coding for a $100 million project began in spring 2013 for an October 1st go-live date, but we will go on. Cost by the time the system went live was almost $300 million, and as most of the people who were in the U.S. at the time would know, when the system went live, it was plagued by slow performance, downtime, lost data, incomplete functionality, and other problems. One estimate was that only 1% of people were able to use the site as intended at first. So clearly a challenge project in many respects. Now what's interesting about this is how the people who were involved in the project diagnosed the problems with Healthcare.gov. So contemporary newspaper reports, meaning October of 2013, characterized the problems with the site as being not enough testing. So you can see from the headline here from USA Today, the government did not test the healthcare site as needed. And in case you missed the fact that it was about testing, the subheading also says, did not test the Health Exchange website as much as it needed to. And in case it's still not clear, the first sentence in the article says not enough tests were performed. And in case you still haven't gotten the picture, the quote in the first sentence of the second paragraph says the system just wasn't tested enough. So it seems pretty clear that the people directly involved with the project reporting the issues at the time thought that the problems had something to do with testing. Now let's dig into that a little bit and see whether we agree that that's the case. Other details reported in articles at the time said things like, we all know we were working under a compressed time frame to launch this on October 1st. Well, compressed time frame says something different to me than not tested enough. I wrote a whole book called Rapid Development about development under compressed time frames. There are all kinds of dynamics that come into play when you start working under a compressed time frame that don't have a whole lot to do with not enough testing. Another comment said that during House hearing, contractors said CMS decided at the last minute not to allow people to shop for plans. Now that's interesting. Decided at the last minute. What does that mean? Well, to me, with my software guy hat on, that says there were late requirements changes in the project, which again doesn't really have anything to do with testing. Another comment, officials were still changing features of the website as late as the last week of September for an October 1st release. Absolutely crazy and nothing to do with testing. Absolutely has to do with requirements. And then here's one. They had just 2 weeks to test the site before all the pieces from several contractors had to work together the day of the launch. Now I could do a whole talk on that one sentence. This I think is characteristic of projects that start out being behind schedule. Basically, there's work going on in the project that no one wanted to admit needed to be done, namely significant integration work from the several contractors, but basically because everyone was under so much schedule pressure, nobody took ownership of that work and the work just didn't happen. The idea that they were going to just put the pieces together at the last minute and see if they worked on the day of the launch is just laughable. That's something that people would have reported as a bad practice in the 80s. We certainly should know better today. And then, interestingly enough, determining many of the problems the system would have after the various parts were integrated was difficult until the site actually went online. Wow, that's quite a statement too. So they weren't going to actually know whether it worked until it went online. A very scary statement. It was the agency's responsibility to make sure all the parts worked together. So again, basically there was too little time on the project. Nobody wanted to take responsibility by default. It was the agency's responsibility to make sure all the parts worked together, but the agency didn't have the expertise to do that, which is why they hired a contractor for this project in the first place. The technology is there to do that. It just requires foresight. Now, this galls me more than anything else on this slide, which is it just requires foresight. It's basically saying it just requires an adequate amount of planning, which of course I would completely agree with, but it's sort of implying that they didn't have an adequate amount of planning, which I think is actually quite clear from the results. So, bottom line is, how does all this add up to not enough testing? It doesn't add up to not enough testing. It has very little to do with not enough testing, and yet the people intimately involved with the project thought that testing was the culprit. When I think quite clearly, just from reading the newspaper reports at the time, you could tell that it really didn't have very much to do with testing. Now, interestingly enough, if we apply the 4 factors model, which is essentially what I did at my executive summit in 2013, if we look at the size of the project, it's a short schedule, it's a huge budget, $100 million, huge staff ramp up. There's a good argument to be made that you cannot meaningfully spend $100 million worth of development effort in the amount of time they had to do the project, and clearly the planning was not matched to the project size. I think this gets a pretty good red circle on the size factor. Uncertainty, we had numerous immovable requirements or laws, and so those put some constraints on the project, but we had massive and late requirements changes, and we also had some significant unprecedentedness in the nature of the application that was being built. I would actually give this, characterize this as red on the uncertainty factor as well. On the defect front, the approach to QA was not matched to the size of the project or the nature of the uncertainty. We don't really even have to talk about the details. We can just tell from the reports that it really doesn't have to do with testing. It has to do with end-to-end quality assurance practices, and here too I would give this a red circle. Now, human variation, interestingly enough, what was that? We don't get a lot of information about how good or bad the staff was on the project, and you know what? It doesn't matter, because when we're talking about software engineering judgment as opposed to analysis, if we've got red lights on the first 3 factors, it doesn't really matter whether the final factor is red, yellow, or green. We know that we're going to have a failed project, and that goes back to that whole idea of judgment, not needing to know every single detail. All right. Now, interestingly enough, the GAO, the Government Accounting Office, issued a report in July of 2014 that concluded substantially the same thing 9 months after I gave my talk in October of 2013. Is that 9 months? Maybe it was November of 2013. That concluded basically the same thing, that Healthcare.gov suffered from rush schedule, changing requirements, lax oversight of contractors, and lack of effective planning and oversight practices. And so the interesting thing is, I think that I gave a very similar assessment just a few days after it went live, just from reading the newspaper, and I believe that anyone can do this if they understand the 4 factors model. So I'm not saying I have any particular unique attributes in this area or skills in this area, but I do think that I have a way of understanding projects through the 4 factors model that if others can apply that, they would understand things just as well. Now, let's turn to a more recent example. As if we didn't get enough problems with healthcare websites in 2013, in 2013 we had similar issues with a healthcare website in Oregon called Cover Oregon. And the background on Cover Oregon is that in 2011, Oregon decided to develop its own state-level health exchange rather than use the federal government's exchange. And work began on Cover Oregon in 2012 for that same October 1st, 2013 go-live date. Oregon contracted with Oracle to develop the exchange. They received $300 million in federal grant money to develop the site. Now, from a judgment point of view, that's interesting too. The federal government budgeted their project for the entire country at $100 million, but for some reason they gave the state of Oregon $300 million to develop the site just for the one state. I'll leave that as an exercise to the reader to figure out how that logic worked out. So the exchange was still not working in December 2013, and Oregon reassigned 500 staff to process paper applications. By April 2014, the exchange was still not working, Cover Oregon was closed, and Oregon adopted the federal program, or the federal website of Healthcare.gov at the beginning of this year, in 2015. The interesting thing about this is that there was some business judgment here that was about as bad as the software judgment. They spent 2/3 of their $300 million budget, about $200 million. They had signed up more than 63,000 people for a private exchange, for private insurance, which generated a per member per month fee of a little over $9. Now, if we look at that, $200 million divided by 63,000 people means it costs them over $3,000 per enrollee to enroll people in the system, and that's just to access the exchange. That doesn't include the cost of the actual health care. Now, if we do some math on that, they're getting $9.38 per month per enrollee, and that implies that they would pay off the system in 28 years. So, again, just the business judgment here is just kind of appalling and really goes to show that absence of judgment is by no means unique to software professionals. And all that is interesting except for the fact that none of those people were actually signed up using the exchange. The exchange never actually worked, so the 63,000 people were actually signed up on paper. So essentially all that money went to sign up no one, which is an even worse matter still. All right, so reported problems with Cover Oregon included code quality is subpar. There was no impact analysis prior to coding. No peer review. Details on software check-in, check-out, and merge processes are lacking. No skilled software development engineering manager. The status reporting lacked basic information, including number of calendar days. They had poor design, even worse code. The quality of work was atrocious. They broke every single development best practice that Oracle themselves have defined, and these are all direct quotes from the assessment of the project. OHA and Cover Oregon lacked the skills, knowledge, or ability to be successful. So how would this stack up using our 4 factors model? Well, the size factor, they had huge budget, huge staff ramp up, and apparently no aspect of the development was matched to the large size of the project, none of it. So we have to give that a red rating, a red light rating. Uncertainty, we're going to skip for now. Defects, they had 0 meaningful QA practices and evidence. Again, red light on that pretty clearly. Human variation, they were massively underskilled according to the report, so we give that a red light as well. Going back to uncertainty, again, from a judgment point of view, it really doesn't matter. If we've got 3 red lights on size, defects, and human variation, that's pretty much all we need to know. The project's not going to be successful with bad performance in those 3 areas, no matter what approach is taken to uncertainty. Now, I also would say that these are not just little red lights, they're huge red lights. They were blatant, massive failures really across the board. And I think it's important to understand that there is nothing subtle about what went wrong with this project. If it hadn't been a project that was performed last year, I think you could argue that it's even contrived for purposes of presenting in this presentation, but this was a project that was still ongoing to the tune of $200 million last year. And that's interesting in itself. Because what we see here is that it isn't just subtleties in judgment, it's really large-grain decisions on this project were wrong. And so we don't have to get down into the details. We should understand that the problems on this project were so conspicuous that this case study seems almost contrived to make a point, but it's not. You would think we would have learned these lessons decades ago, but this project was still ongoing very recently. Now, there's a very nice book called Made to Stick, which is a marketing book, but it describes something called the curse of knowledge. And the curse of knowledge is basically where you understand something so well that you become incapable of explaining it to others. And I've been doing this software development thing for about 30 years now. My first book came out 21 years ago, or actually 22 years ago, so I've been doing this for a long time. The more time goes by, the more difficulty I have knowing what is obvious to other people and what is not. The problems with this project seem completely obvious to me, and yet somehow this project was allowed to go wrong by intelligent people and in a government context where there are multiple levels of oversight to the tune of $200 million. And I find it almost inconceivable that this was allowed to happen, and yet clearly it did. So I think it's pretty clear that the problem in this case was not the absence of analysis. It wasn't subtle miscalculations or subtle errors in judgment, but it was gross errors in judgment. I think we end up asking the wrong question. When we ask the question, what went wrong with this project, we assume that it was ever positioned for success and something specific went wrong. Really, I think the more meaningful question to ask is, why did anyone ever think this project would be successful? And I think that is actually a much harder question to answer. All right, so let's skip ahead then to our third case study, which is the Chrysler C3 project. And now we're going to look at projects that aren't so conspicuously bad as the first 2 projects we looked at. The C3 project, of course, is the original extreme programming project. Now, on this project, Chrysler wanted to replace a number of different legacy COBOL payroll systems with one system. The project didn't make much progress from 1993 to 1995, and in 1996, Kent Beck was hired to build the system. He, in turn, hired Ron Jeffries. Kent and Ron implemented pair programming, continuous integration, on-site customer, unit testing, refactoring, you ain't going to need it, all the practices that eventually became extreme programming. Initial release was 2 months late on a 12-month schedule, which the team considered to be basically on time. After that, progress for the next few years was mixed and characterized by just one more requirement syndrome. They had some difficulty actually making further releases, and then further development was finally halted when Daimler bought Chrysler in 2000. So, from the 4 factors model, what does this look like? Well, from the size point of view, this is a pretty small project, and the planned scope was pretty close to the real scope, so I give it a green light on the size category. On the uncertainty side, I think payroll is a well-understood area, but we had this very kind of rich and possibly contradictory set of legacy systems, so I think there's some uncertainty that arises from that. On the defect side, I think the practices for removing defects were reasonable, pair programming and so on, and matched to the size of the project. I think the reality is this is not a high defect potential project in the first place because it's essentially taking existing system or systems and simply reproducing them in a different technology. And on the human variation, we have to give this a green circle. Not only do we have to give it a green circle, we have to give it a huge green circle because we've got a couple of rock star programmers. We've got Kent Beck, we've got Ron Jeffries. You know, on a small project with this kind of human, high-end human contribution, it's actually going to be pretty hard for us to be unsuccessful as long as those guys are making the kinds of contributions they're capable of making. So, what else can we say about the Chrysler C3 project? Based on this 4 factors model, what would I say surprises me about this project? My answer is nothing. Nothing surprises me about this project because of the human variation that we see on the project. I certainly don't think there was any secret sauce of the extreme programming practices that I would consider significant on that project. And if I asked the question I asked on the Cover Oregon, why did anyone ever think this project would be successful? I think it's pretty clear why it was successful. We had great talent, we had reasonable practices, and the lesson here is not about extreme programming. It's if you pay attention to the needs of the project and plan and execute accordingly in terms of handling variation and uncertainty, in terms of having good people on the project, and in terms of your defect practices, then the project will be successful. So as I said, nothing about this project really surprises me. I think it at least in the first version, it worked fine, and I think that's easy to explain. All right, the last case study we'll look at today is the Cheyenne Mountain ATAMS project. I think pretty clearly a successful project, and I think we'll see why. The U.S. Air Force had a Cheyenne Mountain upgrade project that was originally scheduled to last 6 years and cost just under $1 billion. 13 years later, the Government Accounting Office estimated that CMU, the Cheyenne Mountain Upgrade Project, was $1 billion over budget and 11 years behind schedule. The new systems had not been completed, that had been completed were not even usable. So in this context, CMU managers commissioned Cayman Sciences to conduct a specific project called ATAMS, and the goal was to replace displays on 20 monitors with displays on just 2 monitors and improve response time at the same time. The project constraint was a schedule of 1 year and a budget of $2 million. So the response to this is that Cayman Sciences appointed an experienced project manager. They conducted development with an 11-person intact development team. The team extensively prototyped the user experience, and when they did that, they found that user demands turned the 2-message 4-display system into a 57-message 35-display system. But this was discovered very early during prototyping, at which point the team tackled the riskiest elements first, and they proceeded to buy the risk down by working from highest risk item to lowest risk item in a disciplined way. Design reviews caught more than 200 major defects and 500 minor defects at design time at a cost of slightly less than 1 staff hour per defect found. Now, if we had let those defects persist into design or construction, of course, it would have cost a lot more than 1 staff hour per defect found. So not great news to find those, but it certainly prevented the even worse news of finding them much later in the project. Root cause analysis was performed for each defect found. Technical peer reviews continued throughout the project. and active management was conducted to assure the peer reviews were performed in a timely way. The team adopted a standard of perfecting each component, that is, removing all defects before moving on to the next component. Project status and task status were displayed in a graphic format that anyone can understand, and project management used the status information to seek out project risks and actively address them. The results of this was that this project was delivered 1 month early on a 12-month schedule, and only 2 defects were found within the first 16 months of operation. And so I think really by any measure this has to be considered to be a highly successful project. So how would we score this in terms of the 4 factors model? Size, this is actually a pretty small project, 11 people for a year. This is not causing me any heartburn in terms of the project challenge related to the scope of the project. Uncertainty, well, clearly there was some uncertainty here. There were some significant requirements changes, but those changes were discovered early. And then the project actively attacked uncertainty in requirements, in quality, in project plans, in risk in general. And so while there was some inherent uncertainty on the project, I think the actions of the team kept that uncertainty in the yellow zone and kept it from drifting into the red zone, which from some of the other project teams we've seen today would easily have drifted into the red zone in a big way. Defects, I think this is a great story. Early requirements defect detection through prototyping detected tons of defects and allowed them to be fixed early and cheaply. They thoroughly reviewed their work on an ongoing basis, again detecting defects early, keeping them under control. There was a cultural focus in the project on maintaining high quality through that standard of perfecting each component before moving on, and consistent application of high discipline at the team level, also reinforced by the manager on the project to make sure the team followed through on its good intentions. So I would say another green light here. And then human variation, again, pretty good story. Skilled project team, intact project team, so people who are used to working together and know how to work with each other, and skilled management. And overall, this leads to a successful project. And I'm not sure that I see anything terribly surprising here either, actually. So when we compare that to the commonalities from some of the other projects we've seen, the first 2 case studies I mentioned, people on the project seem unable to identify even basic dynamics on their own projects, even in hindsight. We see quite a contrast here. There was an awareness of risk and explicit steps taken to address the risks, and then the project ends up being successful. So if we apply the other question I've asked a couple times, why did anyone ever think this project would be successful? Here again, we have an affirmative answer. There are lots of reasons for this project to be successful, not really terribly mysterious, actually. And then another common question, problems are not subtleties, but gross errors in judgment. I don't think we see any gross errors in judgment in this project. In fact, the causes of success in this project seem as conspicuous as the causes of failure did on the other projects, which really kind of says we're not really talking about subtleties in judgment. We're really talking about fairly coarse judgment. The causes of success are conspicuous here. The causes of failure on the other projects are equally conspicuous. And I actually think that's pretty representative of the software world at large. My company has spent almost 19 years doing assessments of projects that have been successful and of projects that have failed or been challenged. And I would say that in general, this is characteristic of what we find, that it is not very subtle, that if you know what to look for once you go in and look at it, you see that the deficiencies are actually quite glaring. So let's summarize what we've covered today. I think, as I said earlier, most of what I've described today seems obvious to me, possibly because of that curse of knowledge. I've been doing this for a long time, and I've kind of lost the ability to tell what's obvious to other people and what's not. But one common theme in the failed projects is that basic project dynamics were not obvious to the people involved in these projects. And giving credit where credit is due, these are not stupid people. These are highly intelligent people, and they're often missing the key points even in hindsight, as we saw in those comments on Healthcare.gov from USA Today. So the question really arises, how can people who are so smart make such bad decisions? And I think the answer comes back to that distinction between analysis and evaluation or judgment. The software professionals tend to be very strong in analysis, so I don't think the deficiency in analysis is really the issue. But of course I do think that the deficiency in judgment is the issue, which can lead to not just subtle errors in judgment, but in some cases gross errors in judgment. And for this reason, I think that a focus on developing judgment in software professionals is important, perhaps even more important than professions that do not select so strongly for analysis skills in the first place. With that, I will turn the microphone back over to Will and see if we have a few minutes for comments or questions.
Thank you, Steve. Yes, and we do have questions, and just shows I'm very impressed with the maturity of our attendees. We have some very good questions here, and let's just move on. Doesn't the use of checklists reduce judgment to analysis?
Yeah, I think that's a fair question. Doesn't the use of checklists reduce judgment to analysis? The way I would describe it is that it puts the first rung of the judgment ladder low enough so that someone whose main strength is analysis can jump onto that first rung of the ladder. At least that would be the way I would look at it. Very good.
Okay, next question. What happens if you have 2 reds and 2 greens? Does the uncertainty on judgment, which one would be the highest?
Yeah, so that's a good question. That would require going into a lot more detail on the 4 factors model, and in particular going into the interaction effects between each of the 4 factors, because there are interactions between the factors in every combination of the factors. And what that means really is that I think you would have a really hard time constructing even a contrived example where you had 2 reds and 2 greens. Just because of those interactions, if you really did have 2 reds, there would be interaction effects with the thing that you want to have 2 greens, and I think you would have, I don't think you're going to see that in practice, and I think even if you tried to contrive an example, you would have a hard time contriving an example that wasn't just absurd.
Very good, and I just noticed that I, in the last 2 minutes, received an additional 35 questions, which obviously in the time that we have are not going to be able to get to, but if Steve is so kind and has the time to answer the questions, we will post his answers on our website as usual, at least the ones that he thinks would, he'll do the final filtering. So, okay, in moving on, the 4-factor model, where does the project lifespan factor in?
Where does the project lifespan, I'm not sure what is meant by project lifespan. Does that mean like an ongoing program for several years, or I'm not sure how to interpret.
Yeah, I would say where there's a one-time delivery or something that's going to anticipate several versions to roll out a product that will live on beyond its initial release.
Yeah, okay, so that would be basically the service life of the software that's produced?
Yes.
Yeah, so I would basically say that comes in particularly on the defect side, on the uncertainty side, and depending, may or may not come in on the size side, but that's kind of where I would put that. I think, Will, with your background, you probably are more equipped to answer that question than I am. But I would say that I think one of the failure modes that people run into with projects that are anticipated to have a long service life is trying to anticipate to too high a degree what capabilities might be required of that system in the future and not focusing enough on the requirements of that system at the present time. In the Agile movement, we've had this whole idea of YAGNI, or you ain't going to need it, so basically focusing on design for today, not for tomorrow. I think that's the wrong way to look at it, frankly. And the Agile movement has also criticized big design up front. They say BDUF as a derogative term. I don't think that's the real issue. We've spent quite a bit of time at my company trying to really put our finger on exactly what is the issue. I do think that that's circling around an issue. And what we've really decided is that the issue is what we've come to describe as design for speculative requirements. And anytime you find yourself designing for speculative requirements, I think that creates, that basically gets you pretty close to a red circle in the uncertainty box. We have a hard enough time coming up with good designs for the requirements we know about. The idea that we're going to speculate about requirements correctly and then that we're actually going to come up with effective designs on top of that for those requirements we're speculating about, I think is a really tall order. So, I think some of that I think most of it, as I kind of think out loud here, in terms of a long-lived system, the success or failure would probably be determined most in the uncertainty factor. Basically, how is the team addressing the uncertainty of a long lifespan of that system? Are they getting overly preoccupied with things that aren't pinned down yet that may or may not happen at some point in the future? So that's the way I would look at it.
Very good. I'm going to thank all the people. We're approaching 100 questions here, and I'm just going to try to move off target here a bit and talk about professionalism, because there were several questions dealing with what I call professionalism, the role of the software engineer versus how do you handle management, how do you deal with customers, how do you, as a professional, do you as an individual then embrace the model, the four factors, the Bloom's taxonomy in yourself, and how do you go about becoming a better person and then influencing the overall outcome of project success?
Yeah, in philosophy there's a concept called the principle of charity, and the basic idea of the principle of charity is that if some historically significant philosopher wrote something down, they weren't idiots, and there was probably some reason for it. It may not ultimately be correct, but it's also not just completely stupid. And Jim McCarthy in his book, Dynamics of Software Development, kind of said the same thing when he said, don't flip the bozo bit. Don't just say, okay, this guy's a bozo, so I'm not taking anything he says seriously. Technical people tend to flip the bozo bit on upper management or non-technical managers or sales and marketing people pretty readily, in my experience. And I think part of improving our skills in analysis and evaluation, not in analysis, but rather in synthesis or create and judgment or evaluation, really is actually being more charitable in our interactions with upper management, sales and marketing, and so on. Those folks are often very intelligent people as well, but the nature of their intelligence is different than the nature of the software staff's intelligence. They are not selected primarily on the basis of their analysis skill. They may be selected primarily on the basis of their synthesis skill or their evaluation skill, and so we can actually learn a lot from them if we actually go into those interactions with an open mind and don't flip the bozo bit on them. So that would be my knee-jerk reaction to that question.
Very good, and I'm afraid we've run out of time today, so I'd like to thank Steve once again for his informative presentation and insightful answers to the many questions, and a special thanks for you out there taking the time to attend and participate today. This webinar was recorded and will be available online in a few days at learning.acm.org/webinar. You can find announcements of upcoming webinars and other ACM activities at learning.acm.org and acm.org. And then now we're going to ask if you wouldn't mind filling out a quick survey where you can suggest future topics or speakers, which as I said, should be on your screen. So in closing, this is Will Trace saying goodbye for now. Thanks again for joining us. Hope you will join us again in the future, and in particular, our next webinar speaker is tentatively scheduled to be Bertrand Myers, speaking on Agile, the good, the hype, and the ugly. So take care, and talk to you soon.